Welcome to Math World. Today's class, let us learn a general method to solve a quadratic equations. So far we have used a factorization method and completing square method to solve a quadratic equation. Here we are using a formula. It is a general technique in case you are given with the quadratic equation and have not mentioned any method to solve, then it's better to go for solving this quadratic equation by the formula itself. So let us learn what is the formula and how to get the formula first. A quadratic equation is given to you, say ax square plus bx plus c equal to 0. It's given to you. Then I have explained you while doing the completing square method, if the first term or the coefficient of x square is not a perfect square number, then we go for dividing the whole equation by a. So same thing I'm doing over here, divide whole equation by a. So what will I get? X square, ax square by a is x square, then b by ax plus c equal to 0. This is the first step. And second step is we go for writing x square plus bx equal to minus a. In that form we have to write. So it's nothing but a completing square method only. I'll rewrite the equation like this. Now I have to add b by 2 whole square to both left hand side and right hand side. Here my b is b by a. Say first step is to divide it by a, and second step is writing the equation in the form x square plus bx equal to minus a in this form, okay, and then have to add b by 2 whole square to both the side. Okay, this was the method I explained you in my last video. So same thing I'm doing. I'm adding this just to make this a perfect square. Okay, in this case my b is b by a, right? So b by 2a whole square I need to add to both the side. Okay, I'm adding b by 2a whole square to both the side. Okay, what will I get? X square plus b by ax plus b square by 4a square equal to minus c plus, sorry, c by a. I made a mistake here. I have to divide it by a, no? I'm sorry. Yeah. So c by a, then I have to add b square by 4a square. Now this is a perfect square. In fact, x square plus b by ax plus b square by 4a square. You can take out b of 4a square, you can write it as 2a whole square also. Then it will be a perfect square. I'm not going to write all those steps. I'll just tell you the final step. This is nothing but x plus b by 2a whole square. Okay, if you simplify this, you will get this. No problem with that. Okay, I'm just telling you how to get the formula. 4a square. Okay, then I'll just rewrite the right hand side. This is a, no? So I want, I'll take 4a square as LCM. And this is minus c into 4a plus b square. This can be rewritten as b square minus 4ac divided by 4a square. What was the left hand side? It's x plus b by 2a whole square. Okay, x plus b by 2a whole square is this. Now, if this b square minus 4ac is greater than 0, then I can take a square root, right? If b square minus 4ac is greater than 0, then I can write x plus b by 2a equal to plus or minus root of b square minus 4ac divided by 4a square, which is in turn nothing but root b square minus 4ac divided by root of 4a square is nothing but 2a, right? So x plus b by 2a is plus or minus root of b square minus 4ac by 2a. In fact, this can be rewritten as x equal to, I'm taking this to this side, okay? So it's minus b, 2a common, so I'll directly write b square minus 4ac whole divided by 2a. This is the formula for finding the root of a quadratic equation. It gives you two values, plus or minus. No, once you apply plus, so that you'll get one root, and another time you apply negative sign, so that you'll get one more root. So two values for x, in the sense two roots for a quadratic equation. So this is the formula you need to remember. X equal to minus b plus or minus root of b square minus 4ac divided by 2a. The thing is, this is possible only if b square minus 4ac is equal to 0 or greater than 0. What happens if it's less than 0? Let us learn that. Okay. So you have got two roots. One is x equal to minus b plus root of b square minus 4ac by 2a. That is one root. Another root is minus b square root of b square minus 4ac by 2a. These are the two roots. This is if b square minus 4ac is greater than or equal to 0. Okay. Suppose b square minus 4ac is less than 0, in the sense it is negative, then the quadratic equation has no real roots. Why it's so? Let us see. Okay, that is the nature of the roots. We'll learn that first. While explaining that, I'll give you the reason why it is not having any real roots if this is the case. So let us learn the nature of roots in quadratic equation, or roots of quadratic equation. Case 1, that is if you are getting b square minus 4ac as greater than 0. What happens? What are the roots? X equal to, formula is this, minus b plus or minus root of b square minus 4ac divided by 2a. Right? These are the roots. This value is greater than 0, in the sense it is positive. Right? When it is positive, if it is a perfect square, of course you can find the square root of that. If it is not a perfect square, you can keep it as it is. Okay, so this will be the root, value exists. So if b square minus 4ac is positive, then you can find the roots. Okay, and the roots you can say they are minus b plus root of b square minus 4ac by 2a and minus b minus root of b square minus 4ac by 2a. Of course it has two roots and they are distinct. Okay, then the roots are distinct. Okay, you can say it has got distinct roots. So I'll explain you all this with an example also. We'll take up the second case. If b square minus 4ac is equal to 0, then what happens? X equal to minus b plus or minus root of b square minus 4ac by 2a, right? Now this is 0. They are saying this is 0. Therefore, x equal to minus b by 2a plus or minus 0. So, x equal to minus b by 2a twice we have to write. Once plus 0, once negative 0, minus 0. So, we are not considering that. We are just writing this. So, you are getting same roots, equal roots. Here, you are getting different roots because this value matters. And once you are adding and another time you are subtracting, so you will get distinct roots. Here in this case this value is 0, so this is 0, so you will get same roots. Okay, therefore you can say equal roots if b square minus 4ac is equal to 0. Now let us look at the third case where b square minus 4ac is negative. See what happens actually. See, we are writing the quadratic equation in the perfect square form, right? That is, we are writing x plus b by 2a whole square equal to b square minus 4ac by 4a square. This was we are getting, no? The same thing, this one we were getting this, right? Now this is negative. They are saying b square minus 4ac is negative. This is negative means this whole thing is negative, right? Is it possible to have like that any number whose square is becoming a negative? Is it possible? It's not at all possible. So when this happens, if this is 0, if this is negative, then this whole thing is negative, which is not possible, right? Therefore, there is no real number whose square is b square minus 4ac, in fact, which is a negative number. You can say there is no real number whose square is negative. That is it's mentioning b square minus 4ac is negative, right? So which is not at all possible. Therefore we can say there are no roots, no values for x gives me the real number. So in fact no real roots. See, I'll tell you one, I'll explain you once again. See, when it happens, when this is negative, formula is this, right? Root of b square minus 4ac by 2a, right? Now, if it's 0, no problem. If it is greater than 0, then we can write square root of, say, suppose if we are getting 15, square root of 15. No issues, right? Suppose this is negative, say something minus 15. Then what happens? It's nothing but minus b plus or minus root of minus 15 by 2a. Some values over here, okay? But we are getting a root of a negative number which you cannot define, which you cannot find it out in fact. So it's not a real number then. Therefore we say no real roots if b square minus 4ac is negative. See, just the thing is, depending on this, we are deciding whether the quadratic equation has roots and what is the nature of the roots. So nature of the roots is depending on this. Therefore, we call this b square minus 4ac as discriminant of the quadratic equation. Discriminant of the quadratic equation, that is b square minus 4ac. I repeat, nature of the roots depends on the value of b square minus 4ac. Therefore, we call this as a discriminant of the quadratic equation. This decides the nature of the roots. So sometimes the question will be like, they'll give you the quadratic equation and they'll ask you to find the discriminant of the quadratic equation. Just you need to find this value. Okay. So let us go for the problem. First problem, solve the quadratic equation 2x square plus x minus 4 equal to 0. It's in the form ax square plus bx plus c equal to 0. A value is 2, b value is 1 and c value is minus 4. Be careful while writing these values. A small mistake over here will give you wrong answer. Okay. Now roots of a quadratic equation are x equal to, this is the formula, minus b plus or minus root of b square minus 4ac divided by 2a. Right. So substitute the values of a, b and c. Sorry. B is 1, so minus 1 plus or minus root of b square 1 square minus 4a into c. C is minus 4 divided by 2 into a is 2. Minus 1 plus or minus root of 1 square is 1, 4 4 16, 16 into 2 32, but the sign is positive, so divided by 4. In fact, it's minus 1 plus or minus root 33 by 4. So roots are, one root is this plus root 33 by 4 and another value is minus 1 minus root 33 by 4. Sometimes you'll get a perfect square over here and you can simplify. Some other times you won't get. This is how you have to find the roots of a quadratic equation by using the formula. In fact, this is the easiest way. The thing is, it depends on these values. If they are very large, then it takes time to do the calculation. So first thing, when the equation is given to you, you need to find these values a, b, c and try to remember this formula so that you can directly apply and get the roots of a quadratic equation. Here you got two distinct roots. Okay, discriminant value, if you want, if it is asked to calculate the discriminant value, that is b square minus 4ac. So this is the discriminant, and b square is 1 minus 4ac. So it's 1 plus 32, it's 33. Discriminant value is 33. Second problem. Here a value is 4, b value is 4 root 3, c value is 3. Discriminant There's b square minus 4ac. So b square is 4 root 3 whole square minus 4ac. 4 4 is 16 into root 3 square is 3 minus again 16 into 3. So you are getting a 0 value over here. Discriminant is 0. When this is 0, b square minus 4ac is 0. What is the nature of the roots? Two roots are equal. Roots are equal. And the roots are x equal to minus b by 2a. This much is enough. You no need to write everything. Okay. It's minus 4 root 3 by 2a, 2 into 4. So it's minus root 3 by 2. So two roots are minus root 3 by 2 and minus root 3 by 2. Roots are equal. You no need to write full formula and all. This is only if you get a discriminant value as 0. Next problem. Find the roots of the quadratic equation x minus 1 by x equal to 3 where x is not equal to 0. You just have to take the LCM. You have to rewrite this equation. Write it in the form x this x to the side, so x square minus 1 by x equal to 3. I'm taking LCM. Now take it to the side so that x square minus 1 equal to 3x. Take it to left hand side, x square minus 3x minus 1 equal to 0. So this is in the form ax square plus bx plus c equal to 0. What are the values of a, b, c? A is 1, b is minus 3 and c is minus 1. Be careful while writing a, b, c values. Okay. Now the roots are x equal to minus b plus or minus root of b square minus 4ac by 2a. So b is minus 3 minus of minus 3 plus or minus root of b square, that is minus 3 whole square minus 4a into c divided by 2a. Oh, I'm sorry. Yeah. B value is minus 3 and c is minus 1. So be careful while writing that. Minus of minus 3 is plus 3 plus or minus root of, it's 9 minus into minus plus 4 divided by 2. So 3 plus or minus root 13 by 2. These are the roots. Once you take positive and another time you take the negative value. If you want, you can write it like this also. X equal to 3 plus root 13 by 2. One root and another root is minus 3 minus root 13 by 2. These are the roots, two distinct roots. In my next class, I'll solve few word problems which uses this method to solve quadratic equation, and a few more problems of this chapter. Thank you.